Hi, everyone. Thanks for joining today. I'm here to talk about our journey with Grafana Cloud. So from basically fragmented monitoring to unified observability with Tally Group. So before I get into things, I'll just do a quick introduction to myself. I'm John Bulauan. I'm a senior DevOps engineer at Tally Group. I mainly work around platform engineering, mainly dealing in all of our cloud hyperscalers. Also, making sure our systems are reliable, scalable, and observable. So a big part of my role is making sure that our teams have the tools to be able to effectively do their day jobs and make sure that our systems are operating efficiently and effectively. I'll start a bit about Tally Group. So we're a SaaS-based company, mainly based in Melbourne. However, we are global. We provide global energy solutions across a number of customers, so commercial and industrial, small to medium enterprises, and also the residential market. Over the past few years, the company has reached significant growth. Essentially, Tally Group was a startup and now scaling rapidly. So basically, this means that our infrastructure footprint is growing really, really fast. So we've basically, that is great for business. Essentially, it kind of exposed a gap in our technology suite, more specifically observability. There was a gap there. So our existing capability just wasn't keeping up with the demand. So that's when we had to explore what we would do about solving that. So as our platform continued to grow, one thing was clear: our observability was fragmented. Basically, what that means is we had a fleet of tools that basically did each component in isolation. So it was very hard to paint the bigger picture overall. So it was very siloed. And if we look here, our tooling was split. So metrics and alerting was with one tool. Application logging, IRM, synthetic checks, and the major gap that we had was we had minimal to no application observability. So it was very difficult to be able to go through and deep dive and understand what the root cause was, which application is causing our systems to fail. Our applications call each other quite often. So we were really in the dark with where that bottleneck was. As a result of this, our observability fleet wasn't optimal. When it came to incident management, triaging, and the collaboration, it was very difficult and very time-consuming. Especially like when something went wrong, all of our engineers were just flicking between the different tools, and they had to manually essentially build out all the pieces and put the pieces together, which obviously it increased our SLAs. So it wasn't good. That wasn't good at all. And yeah, it just wasn't a good user experience. Our production support teams and our engineers were finding it quite difficult, flicking between the two. And on top of that, it was quite expensive. We had a lot of vendors. So yeah, over time, it just wasn't cost efficient. So another thing, more specifically about performance degradation, because there wasn't any end-to-end application observability, we didn't know whether the major releases that we had were causing whether it increased performance or decreased performance. So yeah, it was quite difficult to pass over viable information back to our engineers where they could improve and optimize our services. So we understood that there was a gap, and we really sat down and had a decision in conclusion that we needed a unified observability tool to match our platform's growth. Something that could basically bring together everything from metrics, logging, alerting, operational signals into a single pane of glass, instead of having that across multiple tools. It wasn't just to replace tooling. The goal was to create a more cohesive observability experience for our engineers and production support teams. We also wanted to move from a reactive state to more proactive operations. It's not a good look when the client's notifying you that your system's down, so we definitely wanted to get on top of that. Once we decided we needed a unified observability platform, the next thing we had to define was what we were looking for. So it was a platform that allowed us to consolidate all of our observability tools into like a one-stop shop, and obviously application observability and the enablement to become more shifting towards a proactive state. So these were our requirements. So we had to replicate our existing observability capability, so anything from visualizations to our infrastructure metrics, synthetic checks for critical services, logging and metrics aggregation, incident response management, and on-call schedules. Next, we also wanted to identify new capability that we wanted to implement. So that would allow us to give deeper insight into our service behavior, and also fine-grained application level alerting. By separating what we needed to replicate and what we wanted to introduce, we created a roadmap that allowed us for a phased, low-risk approach. And this is where we, had a conversation with Grafana. So we split our Grafana Cloud migration plan into 3 phases. So the pilot phase, so testing the platform with a small set of services. Then moving over to the implementation, so onboarding basically the whole billing engine onto Grafana. And then they'll decommission, so retire the old tools and do a full cutover to Grafana. So this is what the pilot phase looked like. Essentially sitting down with Grafana, mapping out all of our requirements, so that's the engagement. And then out of that, we really wanted to, define our business objectives. So what do we actually need for Grafana Cloud to be considered fit for purpose? It helped ensure that our proof of concept would focus on what really mattered and actually delivered business value. After that, we did our execution of the POC. So basically onboarding a subset of applications, dashboards, testing our alerting, synthetics, to meet what we were looking for. After that, we had a review. So we reviewed all the outcomes, and we asked the questions internally. Did the pilot meet our objectives? Was Grafana Cloud capable of handling our workloads and observability needs? Which it did. So with the go, no-go decision, we decided to go ahead and fully migrate over to Grafana Cloud. From there, this is what our implementation stage looked like. So our implementation is broken down into several components. So with ingestion, so onboarding all the telemetry across, visualization, then transforming some of our telemetry into dashboards, and enriching them with additional telemetry that Grafana provided. From there, we had alerting and synthetics. So we are configuring finer-grained alerts and synthetic checks to move from proactive to reactive detection. So that was that. After that, we did IRM, so integrating incident response workflows so that alerts flow directly into our on-call schedule. So it's separated into two teams, platform and production support. And yeah, using the Grafana mobile app quite a lot is, yeah, very effective. After that, it doesn't stop there. So post migration or implementation, training. So a lot of the team very new to Grafana Cloud. So we had help from our observability architect to come in and provide some training sessions. As you can see as well, just wanted to give a shout out to DNX for helping us with this migration. They came in and really provided the solutions and best practices on how to optimize moving to Grafana Cloud and helping us deliver within 6 weeks. Lastly, our decommission phase. So that was the final step. So how we did this was we ran our old tools and Grafana Cloud in parallel just to make sure that all the validations from Grafana and all the reporting is correct. Once we're very confident with Grafana, we moved over to switching off the other tools just one by one, and then we retired those tools. So that was the migration phase, but basically how Grafana looks at Tele today. It's fully embedded across the board, and I'll show you a graph of where we were. So this is where we were prior. Yeah, a range of tools. They all did their job really well. However, it was just painting that bigger picture. It was very isolated and difficult to go forward with. And now this is today. This is what Tele looks like with observability. Everything flows into one place. Just a bit of a deep dive. This is how it's segregated, but I'll just go through it quickly. So we've got visualizations. One of the main dashboards we look at is our APIs or API gateways and databases. So those would be the two main dashboards we look at. We have our synthetic checks. I'll get into that later. IRM as well. So it's really, very important that we had that set up. And not only does the platform team and the production support team collaborate together, but now we can, involve necessary contacts from engineering. We've just got metrics, infrastructure and logging, application observability, which is a very important aspect, and alerting. I just wanted to talk more about application observability because that was one of the gaps we had with our platform. We heavily rely on Alloy. So prior to this, we didn't really have an overall insight or a low-level insight of what our applications were doing, how they were behaving, performing, and where the bottlenecks were. So we rely on RCA Workbench to really put the pieces together and really understand, which service, not only which service is calling each other, but also which service is, causing the bottleneck. We use tracing, performance metrics as well. It's something that we didn't have in the past. Another big win for us is using the synthetic checks. Yes, we do have the health check endpoints that pings to ensure our microservices are are healthy. However, I just wanted to focus more on our automated daily platform checks. So prior to this, we did have the production support team. They would log in very early in the morning and run a manual SQL script, which basically is part of their validation check to ensure the platform is healthy. But with synthetic checks, we were able to automate this and use a SQL plugin from Grafana back to our databases. And that's now fully automated. So it removes the need and the operational overhead for someone to come in early in the morning. And out of that, whether it fails, we'll get alerted on that, and then we go from there. Just wanted to run through another dashboard. This is our API gateway dashboard. So we use this quite heavily every day. Basically, it just tells us the story around which API is heavily getting consumed for that day, the latency and the response times, and if there's any errors. Another one is our database dashboard. So this is what it looks like. At the top two is very important. So it just determines if there's any slow queries been run and which application that's coming from. So that caused a lot of database issues in the past, CPU spikes. So yeah, now we have the visibility to tackle that quite early. So now I'll go into our results and wins with Grafana Cloud. So let's take a look. So we achieved our goal with a unified observability tool across the platform. We now have end-to-end visibility across the whole platform. We're very confident in our system now. Collaboration is improved because we're able to provide valuable information about our applications and build a story and pass that back to our engineering teams to be able to improve the platform. Our alerts are a lot more smarter, they're more fine-grained. Beforehand, it was quite generic. We faced a lot of alert storms as well, false positives. So yeah, we've been able to reduce that successfully. And we are starting to move over to proactive operations. So we're now notifying the customer and letting them know we're already on it, rather than them notifying us. So that is a really good achievement. Some key learnings with the migration. At the beginning, we started, ingesting basically anything and everything. It caused a very big spike in our costs. But we started to, we enabled adaptive logging and adaptive metrics to be able to toggle on and off our telemetry on demand. It's something that we do heavily in non-production, and prioritize production, so we don't have any of those configurations in production. And yeah, we were guided by Grafana. They came in and analyzed our environment and provided these recommendations. I guess looking ahead, our Grafana Cloud journey doesn't stop here. So what's next for us? K6 performance testing framework. So that's something that we just begun looking into. So we are trying to create an automated performance testing framework to add into our SDLC process. We're also looking at the Grafana AI assistant. It's not just the engineers looking at Grafana, but now people from the business, they want to be able to create their own dashboards. So more specifically, they wanted to create costs-related dashboards. So that's where we're heavily pushing for the AI assistant to help, because they don't know like prompt QL and things like that. So it'll also help with K6. We've done a bit of experimenting where we could get the AI assistant to perform an analysis on our performance testing based off the reports that K6 provides. Multi-hyperscaler rollout. We're not just on one cloud provider. We're heavily now involved in all three. of the main hyperscalers, so Google Cloud, Azure, and AWS. We're about 50% completed, so that's mainly Azure and AWS. Google Cloud is new, so the goal over here is basically to have all the same ingestion patterns across the board so we can pivot accordingly. Doesn't matter what hyperscaler we're with. Yeah, that brings us to the end of our journey from fragmented monitoring to a unified observability with Grafana Cloud. Thank you for listening.